Next question. The problem is here. I repeat the problem once again. Two guns situated on the top of a hill of height 10 meter fire one shot each other with the same speed 5 √3 meter per second. Suppose this is the ground. This is a hill. Hill is 10 meter high. One gun is like this. Suppose this is one gun. Another gun, this angle is 60 degree, so and two velocity is 5 √3, same velocity. So the path of the two shot will be like this, and this will be this. So the two particles meet at the point here. Now what is the coordinate of this point? We have to find out, and the time interval between these. So to solve this, we take time interval t1. Suppose after t1, time interval between two shots t1, and the two shots meet at the point after t seconds from the later, which is later projected. Which is projected later. Now which projected earlier? Now this shot which is at angle 60 degree must be projected earlier, because suppose this particle is denoted by 1, this particle is denoted by 2. Now the horizontal component u1 of x will be cos 60 degree, which is equal to this, and horizontal component of 2 will be 5 √3, because this is completely projected horizontally. Now these two meet at the points same time. This particle should be projected earlier, this particle should be projected earlier. So, and we take, suppose after t second from projection of second particle, the two particle or shots meet meet or collide. Shots collide at point P. So after t second from the position of second particle, second shot, two particle collide. So what is the time taken to reach the particle 1 at the point? This time taken would be t plus t1, and time interval suppose t1, and this time is t. So the condition to meet at the point P will be the horizontal distance covered by each particle should be same. The horizontal distance covered by two particles would be same. So we have x equal to u1x is t plus t1, and u2x into this time is t. So this is distance traveled by second particle, this is distance traveled by first particle. Time now you put u1x equal to 2x equal to, now cancel this, t plus t1 equal to t, so t equal to t1, so t equal to t1. Now considering the motion of particle 1, this particle, the vertical distance, this is the point of projection of two particles 1 and 2 is same, and the vertical displacement of one particle and two particle also same, this is h. So considering the motion of particle 1, vertical motion, so considering the vertical motion of particle 1, this h, what is h? H should be this is h, suppose, and vertical component, so we should take the vertical component. This is 5 root 3 sine 60 degree, so u should be 5 root 3 sine 60 degree root 3 by 2 t, and g is negative, so minus half t square. Now here time taken is suppose t dash means time taken, this is t dash, so t dash should be t plus t, that is 2t. So we will put here t dash equal to 2t. So 15 by 2 into t dash equal to 2t minus half g 10 into t dash. This is h. This is h. Now consider the vertical motion of particle 2. For particle 2, the particle 2 projected horizontally, so using the equation this, we get h is and if we take the sign convention, then h should be negative, and here also h should be negative. U is vertical, we considering the vertical motion, so here u is 0 into t square. Here time taken with t, so equating this and this, we get equating this and this, we get so after 1 second the two particle, so after 1 second two particle meet here, after 1 second two particle meet here, Now what is the coordinate of the particle? What is the coordinate of particle? We get h equal to, from here, 5 into p square, that is 5, h equal to 5. And the what is the x coordinate will be horizontal velocity 5 root 3 into time taken t, horizontal distance equal to velocity into time, so x equal to this and h equal to 5. So total, if this is coordinate, if this is origin, then the coordinate of this point is x and y. So x will be what is x? So x will be this and y will be 10 minus h. What is h? H equal to 5, that is 5. So coordinate will be this. This is the answer. Two towers sitting are Next problem is this. I repeat the problem once again. Two towers AB and CD. AB and CD. Suppose this is AB and this is CD. Two towers AB and CD are situated a distance d apart, as shown in figure. Two towers situated at a distance d apart. AB is 20 meter. AB is 20 meter. This is 20 meter high, and CD is 30 meter high. CD is 30 meter high. Okay, CD is 30 meter high from the ground. An object of mass m is thrown from the top of AB horizontally. A object of mass m thrown horizontally from the tower AB and with a velocity of 10 meter per second. Here velocity u, suppose u1, take u1, u1 is 10 meter per second. 10 meter per second and towards CD. Simultaneously another object of mass 2m. This object mass 2m is thrown from the top of CD at an angle of 60 degree to the horizontal, towards AB with the same magnitude of initial velocity as that of the first object. That is, this velocity also 10 meter per second, but at an angle 60 degree horizontal. The two objects move in the same vertical plane. So that they collide in mid-air. The two particles must move along same vertical plane. If the vertical plane would not same, then they cannot collide and stick to each other. Calculate the distance between the tower to find the position where the object hits the ground. This is the problem. So we have to find the distance and where two body hits here. Suppose this is two bodies collide at here and where this object, that is combined object, hits the ground. So we have to consider this or this where the combined object strike the ground DD. So to solve the problem, so this is 20, 30 and 10 meter per second, 60 degree. So I draw the picture once again. What is given? This tower is AB, which is 20 meter high. CD is 30 meter high. This of mass m moves horizontally with velocity 10 meter per second. This object of mass 2m moves with same velocity. This angle is 60 degree. Now two particles collide here. Suppose two particles collide here. Now what is the position now? The combined particle, suppose here or here, at which position the combined particles strike the ground, we have to calculate this. Okay, this is the diagram. So we have to find the position at which and the time taken and the distance between two towers. Now to solve the problem, we draw. To solve the problem, take this is x-axis and this is y-axis. So initial values, this is particle 1, this is particle 2. Now this distance, suppose from this height is h. Take this height is h. Now what is this height? Height will be 20 minus h. And if this is the h1, then what is this? This will be 30 minus h1. 30 minus h1. So we have this plus h1. This height is the h1. h1 means this height. So we have 20 minus h plus h1 equal to 30, because this is 20 minus h1 and this h1, so this plus this, so this plus this will be 30. Total height is 30 here. 30. Now what is h? Considering the equation of motion 1, what is h? h equal to vertical distance moved, so h equal to horizontal, suppose velocity 0, horizontal velocity 0, we consider only vertical velocity. So vertical velocity of that particle is 0 t plus half gt square. If we take sign convention, so minus h, and here also minus h. That is finally we got half gt square. And what is h1? For h1, to calculate the h1, now we should take the vertical component of this velocity. Vertical component of particle 2 is the particle 2 particle projected here. So we take this is u. So u, that is u cos 60 degree, and along this is u sin 60 degree. Okay, so u is 10. So for particle 2, for motion of particle 2, this h1 equal to minus u sin 60 degree t minus half gt square. So h1 equal to u means 10, sin 60 degree root 3 by 2 t plus half gt square. h1 will be this and h will be this. Now from this equation we get 20 minus h plus h1 means this, this will be 30. So cancelling this and this, we get 5 root 3 t equal to 10, that is t equal to 5 to 2 by root 3. So after this second, two particles collide at here. Just considering the equation of motion of one, the vertical distance traveled by the particle 1 is this, and vertical distance covered by the particle 2 is h1. So this should be 20 minus h1, and this should be h1. So this plus this is 30. This plus this would be 30. So from that equation we get h and h1. So put h and h1 at here. From that we get the time. So we get the time taken t. Now what is the position? At which position the particles strike after the collision? The two particles combine to each other. The two particles combine at here. At which position the particle will strike? Is the particle strike at here or here or here? Now we have to analyze the equation motion. The horizontal total, we have to consider the momentum. When two body collide each other or stick together, then we have to consider the momentum together. Considering the equation, considering the conservation of momentum. No external force is applied. So we can conserve the conservation of momentum. Total momentum before collision equal to after moment. Total momentum after collision. So this momentum we should take along x-axis. So now the momentum of particle 1 is m into u, and momentum of this particle would be minus 2m into u cos 60 degree. So total momentum after collision, two particles stick together, and we don't know the velocity after collision. Suppose this is v dash, then what the value v dash will be 0 from that equation, because cos 60 degree half mu minus m is 0, so v dash equal to 0. That means after collision the horizontal velocity is 0. That means two body fall directly below the collision at the point of collision. So two body fall vertically, two body combine together fall vertically. At which position? From the point of collision. The two body don't move horizontally. After collision, two body combine fall vertically from the point of collision. Now if the distance is d1, so and if the distance is d2, so we know that d equal to d1 plus d2. Now we have to consider d1. d1 equal to horizontal velocity into time u into t, and d2 equal to this horizontal velocity is e cos 60 degree into t. Distance moved by this plus distance moved by this equal to total distance. So this is u plus u by 2 into t. Now what is u? U is 10. 10 plus 5 into t. T is what? T is 2 by root 3. So 30 by root 3, which is equal to 10 root 3. 10 root 3. 30 by root 3 means if we multiply root 3 by numerator denominator, then what becomes 10 root 3. So this is the answer. So this is the answer. D. Now what is the position of this? If this is, now if we take the position from T, so we can calculate D1. So what is the D1? D1 equal to velocity u into T, which is equal to 10 into 2 by root 3. That means 20 by root 3. So from the point B, the position from point B, the position is just D1 at 10. D1 means 20 by root 3 at 20 by root 3 meter from B. So this is the another answer. Understand, just from the figure we get this h equal to half gt square and 20 minus h. Now this is, if this is h1, so this plus h1 equal to 30. From that equation we get t1, we get t. Now this is, we get t equal to d1 plus d2. d1 means horizontal distance moved. d1 means horizontal distance moved. So we consider the horizontal displacement. So we consider the horizontal component of velocity. Also for d2 we consider the horizontal component of velocity. So this is the horizontal component u, and for this is u cos 60 degree. the velocity of 4 meter per second. A person on the cart throws a stone with a velocity of 6 meter per second relative to himself in the frame of reference of the cart. The stone is thrown in yz plane, making an angle of 30 degree with vertical z axis. Just I draw the picture. Suppose this is x and this is y and this is z. So a car is moving along x direction. Suppose the car is moving this, and a person inside the car thrown a stone with a vertical means here z axis at an angle of 30 degree. So this is given, and so the path of the particle will be like this way, and here a branch. Suppose this is a branch from the tree. Suppose this is a tree branch. A stone is hanging from the branch of a tree. So this is a branch. This is a tree, and this is a branch. A stone is hanging from the branch of a tree, and it strike the body. This particle strike the body at here, and finally the string will like this. So at the highest point from branch of a tree, by means of a string of length L, this length is L, and a complete inelastic collision occurs in which the stone gets embedded in the object. Determine the speed of the combined mass. Immediately after the collision with respect to an observer of the ground, the length of L of the string such that the tension in the string becomes zero when the string becomes horizontal, leaving the subsequent motion of the combined motion. That is, this car is moving in this direction, and a person within the car throws a particle vertically upward, that is in the yz plane. This is yz plane. When we throw vertically, then this becomes yz plane. If this is horizontal x plane, then yz plane is the vertical plane. So, and with vertical it makes 30 degree. So, and this stone strikes a body which is hanging from the branch of a tree, and makes a elastic collision. When two bodies stick together, then we call it the collision is perfect inelastic. So two body combined here and complete a circle. And when the string becomes horizontal, then find the length of the string. If the string in the combined mass becomes horizontal after striking, then find the length. So this is the problem. I draw the picture once again. This is x-axis, this is y-axis, and this becomes z-axis. And this is yz plane. Car is here, moves this direction with a velocity 4 meter per second, and a man here throw a stone which with vertical with 30 degree. So this becomes this motion, and suppose this is a tree. So this is a tree. Suppose from a branch of a tree, a stone is hanging by means of a string. The stone is hanging by means of a string. So this is branch of the tree. So the stone is hanging by means of a string. The length of the string is L. This is L. Now this stone and this body combined after collision and makes a complete circle. When this become horizontal after collision, then find the length of the string. Now The velocity of the cart is 4 meter per second and the velocity of the is 6 meter per second. Okay, velocity of this cart is 4 meter 6 meter per second and this angle is 30 degree. So we take iitjee, I equal to unit vector along x-axis, unit vector along y-axis, and k becomes unit vector along z-axis. So now what is the velocity of cart? Velocity of cart completely 4i, car moving with velocity 4 meter per second, and velocity of stone with respect to cart equal to, the stone is moving from the cart, so we get the velocity of stone with respect to cart, which is equal to 6 cos 30 degree k plus 6 sin 30 degree along yz plane. So we have, this is z, this is y, so 6 sin 30 degree j, which becomes when the stone is in air, we consider only the actual velocity of stone. So actual velocity of stone will be velocity of stone with respect to cart plus v cart, that is because vsc means vs minus vc, so this cancels, so vs equal to v stone, that is we have to write vsc plus vc. vsc means this is vsc, so 3 root 3 k plus 3j, and velocity of cart equal to, you know, velocity of cart is 4i. Okay, so this. Now the problem is when the stone strike this body with horizontally. So when the stone becomes horizontal, then k component will be, the stone will be 3j plus 4i. When it becomes horizontal, then k component must be 0. At the highest point of its trajectory, it becomes horizontal, so vertical component must be 0. So velocity of the stone at highest point, the vertical component 0, so this becomes this. So this, the magnitude of this stone, now the magnitude of the stone will be root over 4 square plus 3 square, that is 5 meter per second. Now it makes a inelastic solution. So m v equal to, after collision, equal collision, and after collision, what is the mass of the two body? 2m, because stone and this body, this particle and the stone, mass of two particle will be same, 2m into v0. v0 is the mass of the v0 is the velocity of the combined mass, v0. So we get v0 equal to v by 2, that is 2.5 meter per second. So with this velocity, two body moves and it completes a quarter circle, so that it becomes the horizontal. When it completes a quarter circle, then it becomes the horizontal. This is the horizontal position. So now the motion of the combined body will be in vertical plane. So vertical plane means it moves against gravity. So change of kinetic, we have to consider the energy conserved. Energy is conserved in vertical plane. So energy is conserved under gravitational field. So change of kinetic energy equal to change of potential energy. Kinetic energy change is half 2m v0 square minus 0, because here kinetic energy maximum, here kinetic energy 0. So change of kinetic energy equal to change of potential energy. Potential energy change becomes 2m into g into L, because height gained is L, So this cancel, v0 is this, so L becomes, this is the length of the string. This is the answer. That is, next problem is a particular projectile comment. 10 1 Here the figure is this 45, 30, 48, 41, 60 degree, and that is the point P, 2, perpendicular to this, perpendicular to this, perpendicular to the plane OPT as shown in figure. After time T, second, there separation was minimum and found to be 70 meter in find distance AB. Find distance AB. G1 8, G2 16, G1 equal to 8, G2 equal to 16. So I repeat the problem once again. The particle is projected from an inclined plane OP1 from A with respect to G1 at an angle 60 degree in horizontal. This is velocity. This particle is projected with velocity this at an angle 60 degree horizontal. At the same instant from the point B, another particle is projected at an 90 degree from the plane. Suppose this is plane P1, this is plane P2, and perpendicular to the plane OP2 as shown in figure. This is OP2, this is OP1. After time 10 to 3 seconds, their separation was minimum and found to be 70 meter. Suppose this particle moves in this direction and this particle moves, they don't collide. This and this. So the separation becomes 70 meter. After that time, now find the distance AB. What is the distance A and B? That is this distance. You have to calculate this distance. Problem here. You understand the problem? First you understand the problem. This is a plane OP1. This is plane OP2. Okay. Now the body is projected at an angle 60 degree horizontal. This is 60 degree. This is 60 degree. And another particle is projected at an angle 90 degree on the plane OP2. Suppose this particle moves along this path and this particle moves along this path, so they don't collide. And after some time, the distance is minimum. This distance is minimum. After some time, then what is the distance between this and this? Distance between A and B. You have to find the distance. Minimum distance is given 70 meter. Problem here. Now I draw the picture. This is 45 degree and this is 30 degree. Then another, this is A point, this is B point, this is projected with 90 degree. Given V1 equal to 8 meter per second, V2 equal to 60 meter per second. Okay, this is 90 degree, 60 degree. Now the particle moves like this way, V1 moves like this way, and V2 like this way. They don't collide. What is the minimum? The minimum distance after some time is 70 meter. After t equal to giving 10 root 3, t equal to 10 root 3. Then you have to calculate the distance AB. Now to solve the problem, we have to consider the relative motion. First, we take a x-axis and y-axis as our convenient. First take x-axis and y-axis as our convenience. So let this is x-axis, and this becomes y-axis. This is y-axis. This is x-axis and this is y-axis. So we get V1x equal to V1 cos 60 degree, that is 8 4. suppose this is I. We don't take their unit vector, just we understand. V1x magnitude, we take the only magnitude, we take only the magnitude. V1x equal to this, V2x equal to V2. Now what is the angle here? If we draw the horizontal, this is 30 degree, so this is 30 degree. Now this becomes 60 degree, this becomes 60 degree. So V2x equal to V2 cos 60 degree, which is equal to minus 60 into half, that is 8. Now V12x equal to V1x minus V2x. We know V1x minus V2x, that is 4 minus 8, because this is along negative axis, this is along positive axis. So we have to take this. Now V1y. Now what is V1y? V1y equal to V1 sin 60 degree, which is equal to 4√3, and V2y equal to, this is 60 degree, V2y equal to V2 sin 60 degree. Now what is V2y? V2y equal to V2y equal to, this equal to 8√3 minus 4√3. So this. Now if we consider that, now if we consider V21x, then this would be minus this. Now what is V21 magnitude of, now what is V21? V21 equal to V21 x I plus V21 yj. This, so magnitude of V21 becomes root over this square, this. So magnitude of V21 equal to this. Now if we take the velocity of particle 1 is at rest, if this is at rest, then this particle moves with velocity this. If we take this is at rest, then this particle moves with velocity V21. So the path of this will be, path of this will be along this direction. This is V21. If we take the particle is at rest, then particle 2 will move with velocity V21. Now the minimum distance should be this. This is the minimum distance. So let this is A, this is B, this is C. Now AC is given 70 meter, and we get BC equal to velocity into time. Velocity becomes, and time is 10√3, so 240. Now we have to get AB. Now ABC triangle is a right angle triangle, so we get this is 90 degree, so we get AB square. Pythagoras theorem, this is hypotenuse, AC square plus BC square. AC is 70, BC is 240, so AB equal to what is, that is 250. This is the answer. So from this we get AB, distance AB. This is the end of the class today. Students, subscribe my channel to get more and more such type of video. Okay, thank you, welcome.